The number 0.000000000000639 is equivalent to which of the following expressions? We've got some options. Let's go. That's a lot of zeros, right? This problem is not super hard, but I bet there's one point of confusion that many of you have, and I want to clarify that point of confusion. But for starters, when we're putting something in scientific notation, what we're really trying to do is move the decimal so that it goes right behind the first non-zero digit that we have. Again, we're moving the decimal so that it goes right behind the first non-zero digit that we have. So if we're trying to write the decimal after the first non-zero digit that we have, that means I want that decimal to end up right over here after the 6, because I want it after the first non-zero digit. That's how we get something into scientific notation. And now what we need to do is figure out, well, how many times did we have to move that decimal to get it there? Right? Now, fortunately, the person who typed this problem up for us did some nice formatting where there's spaces so we don't get lost in the zeros. There's kind of groups of 3 here. But if I count how many places this decimal moves, it's going to be 1, 2, 3 spaces to get to here, 4, 5, 6 spaces to get to here, 7, 8, 9 spaces to get to here, and then 10, 11, 12 spaces to get the decimal place all the way here after the 6. So what I know is this is going to be 6.39 times 10 to a power, because what we're doing with scientific notation is we're saying, hey, I'm going to take away all the extra zeros or all the extra place values, if I want to be a little bit more technical, and I want to absorb those into powers of 10. How many powers of 10? It's based on how many decimal places I had to move. In this case, we moved 12 spots. So I know there's going to be a 12 here. But the part that people get confused on with scientific notation is remembering whether it's supposed to be a negative power or whether it's supposed to be a positive power. Like, you probably see this, or you did this, and you realized, well, it's either going to be B, because that has a 12, although it's negative, or it's going to be D, because that has a 12, although it's positive. I don't remember which is which. Here's the way I like to think about it. If I have 10 to a positive number, like let's say 10 to the 5th power, for example, 10 to the positive number is big, right? 10 times 10 times 10 times 10 times 10, that's big. Meanwhile, if I have 10 to a negative number, so let's say 10 to the negative 5th power, well, that means 10 to the 5th goes to the denominator. That's small. 1 divided by 10 to the 5th is really small. So the thing I like to remember is 10 to the positive number is big, and 10 to the negative number, that's small. You may have learned a method where you count left or right to determine positive or negative, but honestly, I find that confusing because sometimes left means positive if you're putting it into scientific notation, and sometimes left means negative if you're taking it out of scientific notation. It just gets to be a mess. So what I like to do is say 10 to the positive number is big, 10 to the negative number is small. And in our case, we're clearly dealing with a small number. So that means when we've moved 12 spaces, I should really think of this as 10 to the negative 12th power, because this is a very small number, meaning it's much less than 1. So our answer in scientific form is 6.39 times 10 to the negative 12th, which means our answer is B, not D. Our answer is B, and if you got it, good thinking.